Hello everyone. Welcome back to another Flutter tutorial. In this tutorial, we will build a simple to-do application using Flutter Bloc and understand the concepts of block. Let's start with the pub/spec file by adding the dependencies. We need Flutter_Bloc, equatable, and for the local database, we will use the Isar cross-platform database for Flutter. Let me quickly show the Isar website and take you through the setup needed. For adding the required dependencies, you can use these commands. This will add required Isar dependencies to your pub/spec. Run the command in your project directory terminal. You can run flutter pub-get to install all your dependencies as you know. Now we will create all the basic folders needed to organize our project. We will need folders, block, models, screens, utils, widgets, etc. Now that we have created the folders, let's add the files needed for block first. Create files to-do_block.dart, to-do_events.dart, to-do_states.dart. Let's begin with the events. Create an abstract class named toDoEvent that extends equatable and add a const constructor. Next, we will include additional classes representing the events required for our app. Given that we are developing a to-do application, we will require events for initializing the database, retrieving, adding, updating, and deleting to-dos, along with an additional event for setting the current to-do in the block state. We will do the same inside the states file. Create an abstract class named toDoState that extends equatable and add a const constructor. Next, we will include additional classes representing the different states required for our app. We might need to listen to below states. A state when database initialized, state when to-dos loading is complete, a state when adding, updating and deleting to-do is completed. And also a error state and one to get the current to-do current state. And some additional events like to-do add in progress to listen to the state when to-do add is started and ended, similarly for update and delete. Make sure to override the props for all the states. We have the basic states ready for our app. Now, we will create one more folder called repo to define actions on our repository, where the local Isar database resides. Create class named toDoRepo and declare a variable to hold the Isar local database instance. The initDB function will initialize the Isar database. First get the directory using getApplicationCacheDirectory method. Then call isar.open with the schema and directory. But at the moment we don't have a schema. Let's create it. Let's begin by creating a new class inside the model folder, named todo. Now, let's examine how to annotate a class for the Isar library. According to the documentation, we need to use the @collection annotation to annotate a class. Let's copy the code snippet and paste it into our todo class, then modify it accordingly. Rename the user.g.dart import to your class name, which should be todo.g.dart. Rename the class to todo, and rename the members to note and completed. Once that is done, we need to run the following command in our terminal, flutter pub run build_runner build. This will generate the corresponding schemas. You will notice a file named todo.g.dart created in your model directory. If you examine the file, you can see the to-do schema generated. Now we can use this schema to initialize the database. Let's update the initDB method in our repo class accordingly. Next, we will write the database methods to save, update, delete, get a to-do, and get a list of all to-dos. To save the to-do in the database, we can utilize the isar.writeTXN method and use the put method to save or update the to-do object in the database. Similarly, we use the .get method to retrieve a to-do from the database using its ID. We might not need this method, but this is the way to retrieve a to-do using its ID. To retrieve all to-dos, we access the isar.todos collection, which is generated for us by the Isar library. Then, we sort it by the completed field and use the findAll method to return all to-dos. To delete a to-do, simply use the delete method in the Isar collection instance, providing the to-do ID. Perfect, that's all we need for the database operations. Now, let's implement the to-do block using all these methods. Create a class that extends block and sets the types as to-do event and to-do state. Then, declare an instance of the to-do repository and call super with to-do init state. Let's add a const constructor and also correct the states to extend from to-do state. Next, we will define the methods to be fired on each event. First is the init method that initializes the database and emits an initialized state. The receiving UI will receive the state and understand that the DB is initialized and then move forward with other database operations. Then we add the add-to-do method. This method will first fire the to-do add-in-progress state and then call save-to-do in the to-do repo instance and then emits the to-do add state with true or false. Let me correct the state names and update the method accordingly. Now, let's call the save-to-do method from the to-do repo inside a try-catch block. We will update the add-to-do event with a to-do member because we will be receiving the to-do object from the UI with the user input data along with the event. We will also update to-do add state with a Boolean parameter. If the database put command is successful, then we emit to-do add state with a true value. If there is any issue, then we emit to-do add state with a false value. We will replicate the same for the update to-do method, replacing the event with update to-do event, progress with to-do update in progress, and emitting the result with to-do update state with true or false value. Instead of save to-do, we will call update to-do on the to-do repo instance. Technically, here both save to-do and update to-do are doing the same job. You can even combine them into one function if you want. This is just for simpler understanding of this tutorial. We will update the same for the delete to-do method, replacing the event with delete to-do event, progress with to-do delete in progress. We will need a to-do parameter in the delete to-do event because the to-do object to be deleted is sent along with the event. So let's update the delete to-do event class. We will also update the to-do-delete state with Boolean parameter to notify a success or failure just like the to-do-update state class, and emitting the result with to-do-delete state with true or false value. And we will call delete to-do on the to-do repo instance to delete the current to-do from the database. The next method we will add is load to-dos, which will fetch all the to-dos from the database. The event to be fired is the load to-do event, then first emit the to-do loading state and fetch to-dos from the to-do repo instance by calling the getToDos method. Then we emit the result using the to-do loaded state with the list of to-dos, and also if there is any error, we emit to-do error state with the error message. So, for that, we need to update the to-do loaded state class with a list of to-dos parameter. Let's do that. Also, update the to-do error state with a string parameter error to notify the UI about the error. Remember, you can emit any object here, we are trying to keep it simple. Next is the setToDoNote event where we set the current to-do that is being either added or updated. Let's update the setToDoNote event with a to-do parameter and also the emit to-do current state with current to-do from the event. Now it's time to fire all the methods above, based on the events fired from the UI by the user. First is the initialize event that initializes the database. The addToDo method will be called on addToDo event. The updateToDo on updateToDo event. The deleteToDo on deleteToDo event. The loadToDos on loadToDo event. And finally, setToDo method will be called on setToDoNote event. Next is the main part where we will wrap our root material app with the block provider. Remember, you can wrap the block provider anywhere in your application. In this example, we are wrapping at the root of the application. On create of the provider we are firing the initialize event which initializes the database. The create method must return the instance of the block, here the to-do block. Also you can have multiple block providers using the multi-block provider instead of block provider. Here we have only one, so we are using the block provider. An event is fired by calling add on the block instance with the event name and the parameters if any. Then we will add the material app as the child of this block provider. Next, we will quickly write some utility functions to call the block functions. This is just for convenience and nothing to do with the block. We will write functions for refreshing, add, update, delete and setToDo. You will notice that there are multiple ways to fire an event. You can either use blockProvider.ofContext or you can use context.read with the block type, then fire event using add method and pass your desired event as parameter, along with the event parameters if any. Now we will create a utility class for navigation. Here we will declare a navigator state key which we will use for navigation. So declare final global key, type navigator state equals new global key navigator state. We will use this as a global navigation context. Next, I will copy couple of functions for showing a snack bar and closing snack bars in a utils class. Next, we will start creating the home page. We will start the body with the block listener widget, set the types to to-do block and to-do state, set the child as block builder widget. I will pause here and explain the difference between block listener and block builder. Block listener is used to listen to state changes emitted by a block and execute some logic based on those changes without directly rebuilding the UI. It is typically used when you need to perform some side effects in response to state changes, such as showing a snack bar, navigating to a new screen, or performing some other action. Block Builder is used to rebuild a widget in response to state changes emitted by a block. It listens to state changes from the block and rebuilds its child widget whenever the state changes. Block Listener does not rebuild its child widget when the state changes. Instead, it provides callbacks to handle state transitions. Block Builder is typically used when you want to rebuild a part of your UI based on changes in the block state. Let's add the Block Listener and the Block Builder. So here, we will build and return different UI based on different block states inside the Block Builder. If the current state is initialized, then we return UI with text initialized. If the current state is to-do loading state, then we return UI with text, loading to-dos. If the current state is to-do loaded state, then we return UI with list of to-dos, but for now we will return a sized box and implement it later. If the current state is to-do error state, then we return UI with text, error, and the error message. If the current state match none of these, then we will return an empty sized box. Now, in the Block Listener, if the state is initialized, we will call the load to-dos using the refresh to-do method, which fires the load to-do event and load the to-dos from the database. Next, we will add a new add to-do page to add and update to-dos. This page will take a nullable to-do as a parameter. If the parameter is null, we know that it is an add action, otherwise, it is an update. Similar to our home page, this page will also have a Block Listener and a Block Builder. We will be updating the UI based on the states. If the current state is to-do add in progress state, then we return the UI as saving to-do. If the state is to-do update in progress state, then we return the UI as updating to-do. If the state is to-do delete in progress state, then we return the UI as deleting to-do. And if the state is anything else, we will show the form to add or update to-do. Our form will have a simple text field with the value set as the note from the current to-do. If the current to-do is null, the value set in the text field will also be null. On change of the text field, we check if the current to-do is null. If it is null, we know that this is an add operation, and we need to create a new to-do and set the note value as the value of the text field. Let me quickly show the setToDo event class again and the function where current to-do is set and emitted. If not, we know it is an update, and we update the note field in the current to-do to the text field value. Then we call the setToDo function to set the current to-do in the state. Now our form is complete, and we will set this as the body of the add to-do page. Next, we will notify the user about the status after each operation is complete. Inside the Block Listener, we will first listen for the to-do add state and check for the success values inside it. If it is true, then we will show a snack bar with an appropriate message. Similarly, for to-do update state and to-do delete state, remember we have not implemented delete yet in the UI. After each operation is complete, we call refresh to-do to refetch all the to-dos and update the to-do list UI and then close the screen to go back to the home page. To clean up the code, let me quickly create a function for the listener callback of the Block Listener and move the code to the new function. This is not necessary, but I am just doing a cleanup here. Next we will update the code in the home screen for the to-do list UI when the to-do loaded state is emitted with the list of to-dos. To show the list, let's create a new widget with a list view. Let me create a new file and a widget named to-do list UI. It will accept the list of to-dos as parameter and a callback function when each row in the list is clicked. The build method is gonna return a list view if the to-dos are not empty. If the to-do list is empty, then we return a text saying, no to-dos added. The item builder in the list view is going to return each to-do list row. We will create a separate widget for each row called to-do list row. To-do list row will accept a to-do as parameter and then a tap when the row is tapped. Make sure to pass the parameters in the constructor. We make the parameters required. Now we update the build method to return a list tile. We set the content padding to 0. On tap of the list tile will fire the onListTap parameter function with the current to-do. And the title is going to be the to-do note. If it is null, we will set it to empty. It will not be the case anyways because we will be validating for empty condition. Now that our to-do list row is ready, we can use this in our to-do list view. Return the to-do list row from the item builder. Pass the current to-do from the to-do list using the index and set the onListTap parameter. Set a divider widget as separator. Item count is to-do's length. The onListTap will be implemented in the home page. In the home page we get the list of to-dos from the state as state.todos. On onListTap, we clear all the snack bar messages if any and then call setToDo to set the current to-do in the state. Here we need to open the Add To Do page. But we don't have the navigation functions yet. So let's write those. Let's open the navutils file that created earlier and then write two functions, one to open the Add To Do page and other one to close a screen. We can use the navigator key to get the context for navigation. Now let's call the Open Add To Do page on the To-Do List tab. And also inside the Add To Do page, we call it after each operation, add, update and delete to do. Now let's go to our root material widget of the application and set the home as our home page. So when we finally run the application, we will the error on screen. It says, could not find the correct provider. This is because we forgot to set the block types in the block builder at some part of our code. Let's fix it. Looks like it is in the home page. Add the to-do block and to-do state in the block builder to fix it. Perfect. Now the error is gone and the application is running. Since there are no to-dos at start, it shows no to-dos added, which is the expected behavior. Next we will create a button that triggers the to-do add or update. This widget is going to take the isUpdating as parameter. If the isUpdating is true, then it is an update action, otherwise add. This is a simple icon button widget. This is a simple icon button widget wrapped inside a block builder because it has to change based on the state. The icon will change based on the to-do value. On press of the button we will execute the appropriate to-do, add or update action. We know the current state is to-do current state which gives us the updated to-do. We check for an empty condition here and show error. Or call add to-do and update to-do based on isUpdating value. And we know that the Add To Do page is already listening for different states and will act accordingly. We will add this button as an action button in the app bar. One thing we missed in the state is to update the props with the member variables. Let's update it for all the states. Now let's test our app. We will try adding the to-do and check for any UI errors and fix it. We can try updating few and see if it is working. When we open a to-do you can see that the text field is pre-populated with current to-do's value which we set as initial value in the text field. Looks like our basic functionality is working good. Next we will add a button to delete the to-do. Similar to add update button, we will have an icon button here. And on press of the icon button, we call the delete to-do function to fire the delete to-do event which deletes the current to-do from the database, and once that is complete, we are refreshing the to-do which updates the UI as well. We will add this button to the actions as well. Now let's run the app and see if this works or not. Delete to do is working good. Let's quickly check the code that updates the UI after the event is completed. Let's do few more tests. Looks like there is a bug when we go to add to do to add or update, and when we come back the list disappears. This is because though the home page is refreshing when we come back and the current state is not to do loaded state, but to do current state. Let's figure out how to fix it. We will try adding the build when callback in the block builder. This will build only when the previous state is not to do loaded state. Let's try to run and see if this fixes it. Looks like not. Okay, we will try another way. We will debug print to see what the current state is. As expected, the current state is to do current state, which is the issue. We will open the add to do page and then add the pop scope widget at the root of the page. This will listen when the page is closed or popped off the navigation stack. We will call refresh to do when the page is closed. Let's test this and confirm. Now that it is working, we can remove some unwanted code. So now we can remove the refresh to do method when the add, update, and delete is completed. Let's do some more testing and confirm everything works. Now that everything is working, we will go through the code once again. First we will look at all the states we created, initialized, to do current state, to do loaded state, etc., then the different events for triggering different functions and the parameters associated with it. Then the different block functions and how it is triggered. Then how the Isar database is initialized when the app starts when we call the init method from the root widget of the application wrapped in block provider. The get to do, add to do, delete to do block functions, and then the different UI changes when each state is triggered. You can print and see the different states when each event ID fired. So that's all for this tutorial. The source code for this tutorial is available in the description below. Please leave your valuable comments. Also please like and subscribe if you find this tutorial helpful. Thanks for watching and see you in the next video. Bye.